All right, we're doing the scenario graphing functions. First thing you want to do is make sure you put your name in. Oops. We're going to enter formulas, use the trend line to determine functions, and then interpret trend line values. After completing this scenario, you will be able to use Excel to graph linear equations, format graphs to maximize visual effects, graph parabolas using trend lines, and then interpret those parabolic graphs. So, how do you go about doing this? Well, Excel makes quick work of graphing linear functions on the rectangular coordinate system. After graphing, you can make your graph look very professional. Excel uses regression analysis to make linear and nonlinear trend lines of graphs. And so if you can use that information to answer questions about the graph. Let's get started on this first one. We learned how to graph on page 136. So on page 148, it asks us to graph this equation, 2x plus 3y equals 6. Here's how you can do that in Excel. The first thing it says to do is to select cells D36 to E41, then go to Insert, Scatter Plot, and we want it to look like that. In order to do that, we have to go to Chart, Tools, Layout, and then we're going to change the axes, the horizontal one, so that it's fixed at 1 point each. So now we've got all the numbers horizontally, all the numbers vertically. And then we're going to get the vertical major axes in there. And now our graph is getting closer. Delete the legend. Change the title to 2x plus 3y equals 6. Now our graph looks like that one. Then it says copy the chart that you made for problem 1. Okay, let's copy that. And let's paste it down here. All right. Then it says right-click on one of the points on the graph and select Add Trend Line. Make it look like what you see here, so it's linear, automatic, and then click on Display Equation and Display R-squared. So now our graph is exactly like that one. What's so great about that? Well, the slope is the x coefficient, negative 0.6667, and the y-intercept is 2. And of course, your graph either does or doesn't look like mine. Graphing linear functions, which is a little bit different. A function is an equation solved for y. And so in this case, we're going to multiply by 3 the value of x, and then subtract 7. So if you see here, it's 3 times the x value minus 7, and I use the address, which is C79 here. When I get done, I can drag it down, and now I've solved those 4 points. Follow the formatting rules for the first graph, so we're going to graph this, insert, scatter plot, and we've got our graph. And we want it to look like the one that you see down below there. Well, in order to do that, layout, axes, horizontal, we want to set it fixed at 1. And vertical, we want to set it fixed at 1. And when we do, our graph gets really scrunched up, so let's make it taller and not quite as wide. Delete the axis. We have to put in the vertical grid lines. Getting closer. I want to make sure my boxes are approximately square. How's that? That looks pretty good. And then change the title to f of x equals 3x minus 7. Trend line. Display the r squared on the graph. And if you notice, it tells us that the y-intercept is 3. I'm sorry, the slope is 3, and the y-intercept is negative 7. Your graph look like mine? Make sure it does, because I'm going to go back in and check. You aren't going to get those points without actually having it look like mine. The data table compares the distance s that a ball thrown from a building falls at the time t after release. The building is 400 feet tall, and the ball is thrown upward at 95 feet per second. Make a graph of the data. Insert scatter plot. This time, click on the trend line that is polynomial and display equation on the graph. Let's delete the table and let's go to layout, axes horizontal. We want to have each second show, so let's fix it at 1 second. And let's put in the vertical grid lines. There we go. And we want to call it distance ball from ground versus time. Okay, I'm going to move the stuff around so that my information here isn't in the graph. I'm going to put it up there. Okay. The values of the equation illustrate facts of physics. The negative 16 is related to pull of gravity on Earth. In the USCS system, it's always negative 16 feet per second squared. The x coefficient, well, if you notice, we said that it was from 95 feet, and you notice the x coefficient says 95. So the x coefficient indicates the distance above the ground at the beginning. What does the constant term indicate? Well, the constant term here is 400, and if you notice, it says the building is 400 feet tall, so that would be the distance above the ground at the beginning. What 2 times is it 450 feet above the ground? So we're going to look here at 450 feet, and it looks like about a half a second. And then the other time that it's 450 feet is over here. Looks like about 5.2 maybe. Okay. And then how many seconds did it take till it hits the ground? Well, it hits the ground right over here, right? Which is at 8.7 seconds. So in reality, this part of the graph won't exist because it's not going to go below ground. The data table here represents the distance in feet that a car skids at 68 miles per hour, which is 100 feet per second, and the time after the brakes are applied. The top of the curve represents the distance when the car is stopped. Since brakes don't cause a car to go in reverse, the graph right of the top is meaningless. Yeah, so after you get to the top here, the rest of it doesn't make any sense at all. All right, so let's graph this. Insert scatter plot. And its skidding distance. Oops. Distance at 68 miles per hour. More points we got to get here, huh? What are we missing? Oh, we didn't get the x coefficient. Where did we get it? Did we not pull the right one down here? The x coefficient indicates the initial speed in feet per second. Why is it not allowing the initial speed in feet per second? There we go. And what's the other point that we didn't get? Huh. Did we not put in our name? Yeah, we got that. Oh, does your graph look like mine? Yes. So we got all the points. If you have any questions, you know who to holler to. Talk to you later.